Hi, dear children. Welcome to the fourth lesson of moving charges and magnetism, grade 12 physics. Okay. Today, we will be learning a very important law in magnetism, Biot-Savart law. Like Coulombs law in electrostatics, Biot-Savart law is very important in magnetism. So before I start the Biot-Savart law, I will give a flashback from class 10. In 10th standard, you learned when current flows through a conductor, a magnetic field is developed around it. The direction of magnetic field is given by right hand thumb rule. Okay. The magnetic field lines will be concentric circles. How will you find out the direction? Use right hand thumb rule. Hold the conductor in your right hand. If current flows in the direction of thumb, then magnetic field lines will be concentric circles in this way. The direction in which the fingers gives the direction of the magnetic field. So hold the conductor in your right hand such that current flows in the direction of the thumb. Then the direction in which the fingers curl gives the direction of the magnetic field. So this is a conductor. This is a conductor carrying current in this upward direction. So magnetic field lines will be concentric circles. Okay. So according to right hand thumb rule, the field lines will be curling anti-clockwise. Okay. If the current direction is downward, the magnetic field lines concentric circles, but direction will be clockwise. Field lines curl in the clockwise direction. Okay. Okay. If you want to find out the magnetic field at this point, at a distance r, magnetic field will be into the plane of the paper P. And you see the magnetic field is perpendicular to the plane containing current and R and directed into the plane of the paper. When you go to the left hand side of the conductor, here magnetic field is out of the plane of the paper. Okay. If you want to find out the magnetic field at this point, it will be in this direction. So magnetic field lines is always perpendicular to the plane containing direction of current and R. You remember that. Okay. The magnetic field, the strength of the magnetic field depend on the strength of the current and distance from the current conductor. Now we will learn about Biot-Savart law. It is very important. Biot-Savart law. Biot and Savart law. Okay. Biot-Savart law. See, this law gives the magnetic field at a point due to a small elementary length of a conductor carrying current. See, I'm drawing a conductor. This is a conductor, but it is not straight. It has an arbitrary shape. Okay. And you imagine a small element of the conductor. Imagine a small element of the conductor. Current is moving in the upward direction. Current direction is shown. So imagine a small element of the conductor. Say this is a small element. I name it AB. So when current passes through this conductor, through this element, a magnetic field is produced. I am considering a point P here. And I join the midpoint of the element AB to the point B. This distance is R. And I am drawing a tangent to the current for the element AB, this one. This shows the direction of current for the element AB. This angle is theta. Angle between direction of current and R is theta. Magnetic field at the point P I represent as dB, small magnetic field. This magnetic field will be directed into the plane of the paper. Because current is upward, you have to use right hand thumb rule. Current upward, when you consider a small elementary portion, it can be considered as straight. So current upward, magnetic field will be concentric circles. Field lines will be in concentric circles, anti-clockwise direction. It will be into the magnetic field at this point will be into the plane of the paper. Okay. And this magnetic field is perpendicular to the plane containing current and R. Now I am coming to the statement of the Biot-Savart law. This magnetic field dB is directly proportional to the strength of the current. Directly proportional to the length of the element. Directly proportional to the sine of the angle between direction of current and the line joining the element to the point P, R. Line joining the point P and R, and inversely proportional to the square of the distance between the element and the point P under consideration. So this is Biot-Savart law. So we can combine like this: dB proportional to I dl sine theta by R square. You can remove the proportionality sign by multiplying by a constant. dB equals mu 0 by 4 pi. This constant is mu 0 by 4 pi. I dl sine theta by R square. This mu 0 is known as permeability of vacuum. Permeability of vacuum. Okay. Its value is 4 pi into 10 raised to minus 7 Tesla meter ampere raised to minus 1. This is the value of the permeability. So different medium have different permeability. Mu 0 is the permeability of vacuum. So Biot-Savart law statement, I will tell you the statement again. The magnetic field at a point due to an elementary length of a conductor is directly proportional to the strength of the current, directly proportional to the length of the element, directly proportional to the sine of the angle between the line joining the direction of current and R. See the direction of current shown in the diagram and R. But the sine of the angle between the direction of current and the line joining the element and the point P, and inversely proportional to the square of the distance between the point and the element. This is Biot-Savart law's statement. Okay, once again, I will give you the statement. Biot-Savart law states that the magnetic field at a point due to an elementary length of a conductor is directly proportional to the strength of the current, directly proportional to the length of the element, directly proportional to the sine of the angle between the direction of current and the line joining the element to the point P, and inversely proportional to the square of the distance between the element and the point under consideration, where you find the magnetic field. This is the statement of Biot-Savart law. Okay. Now we can express, so what is the magnitude of magnetic field? dB equals mu 0 by 4 pi I dl sin theta by r square. Okay. Ideal sin theta by r square. This is the magnitude of the magnetic field. Direction. What is the direction of this field? It is given by right hand thumb rule only. It is perpendicular to the plane containing current element dl, idl, and distance r. In this case, it is into the plane of the paper. Now we can express this magnetic field in vector form. So in vector form, dB bar equals mu 0 by 4 pi I dl sin theta by r square. You have to multiply by a unit vector r hat. So dB equals mu 0 by 4 pi I dl sin theta by r square. You know this unit vector property, r hat equals r bar divided by modulus of r bar. So you can substitute here r bar divided by r. So we can write dB bar mu 0 by 4 pi I dl. Okay, IDL I take as one quantity. It is known as current element. If you take current alone, it is a scalar, but current into length, it will be a vector. So it is IDL. IDL is known as current element. We can write this as IDL cross R bar divided by R cube. Okay. Because AB sin theta, A cross B is AB sin theta. I use that result. Okay, dB equals mu 0 by 4 pi IDL cross R bar divided by R cube. This is Biot-Savart law in vector form. Okay. Now we can compare between Coulombs law and Biot-Savart law. See, you know Coulombs law, 1 by 4 pi epsilon 0 Q1 Q2 by R square. That is Coulombs law. Biot-Savart law, you see the equation. dB equals mu 0 by 4 pi IDL sin theta by R square. Both are inverse square law. Both fields are inversely proportional to square of the distance. Okay. So both the laws are inverse square laws. Both the laws are inverse square law. So one comparison, one similarity is what? Both obey inverse square law. Second similarity is both obey superposition principle. Total field is due to the vector sum of all the fields due to different elements. It obeys superposition principle. So comparison between Coulombs law and Coulombs law and Biot-Savart law. Okay. First, similarities I am writing. Similarities. First similarity. Both obeys inverse square law. Both are inverse square law. Both are inverse square law. Second similarity, both obey superposition principle. Both obey superposition principle. Now, some differences. See, the source of, in Coulombs law, the source of electric field is charge at rest, and charge is a scalar quantity. But in Biot-Savart law, the source of magnetic field is ideal. Ideal is known as current element. It is a vector quantity. That is the first difference. In Coulombs law, the source of electric field, that is a charge at rest. So that is a scalar quantity. Source of electric field is a scalar quantity. Source of electric field is a, what is the source? Charge only, right? But in Biot-Savart law, the source of magnetic field is moving current. We can say a current element, which is a vector quantity. In Biot-Savart law, the source of magnetic field is in Biot-Savart law, the source of magnetic field is current element. It is a vector quantity. So that is the first difference. Source of electric field in Coulombs law is charge at rest. It is a scalar. Biot-Savart law, mu0 by 4 pi ideal sin theta by r square. That ideal is the source of magnetic field. That is known as current element. That is a vector quantity. Another difference is in Coulombs law, electric field is along the line joining the charge and the point under consideration. Okay. See, if you, this is a charge, this is the charge, two charges, Q1, Q2. Electric field is along this line only. Electric field is along the line joining the two charges. But in Biot-Savart law, suppose this is the current element, ideal. This is the point P. Magnetic field is perpendicular to this line. Perpendicular to the line joining the current element and the point P under consideration. Okay. This is a second difference. Second difference, in Coulombs law, electric field is along the line joining the charge and the point under consideration. Okay. But in Biot-Savart law, magnetic field is perpendicular to the current element and the line joining the current element and the point under consideration. This is a second law. Second difference. Another difference, In Coulombs law, there is no angle term. Q1, Q2, 1 by 4 pi epsilon 0, Q1, Q2 by R square only. But in Biot-Savart law, mu 0 by 4 pi ideal sin theta by R square, there is a angle dependence. Okay. So in Coulombs law, there is no angle dependence. So this is the third difference. In Coulombs law, there is no angle dependence. No angle dependence. But in Biot-Savart law, there is an angle dependence. In Biot-Savart law, there is an angle dependence. In Biot-Savart law, there is an angle dependence. So these are the comparison between Biot-Savart law and Coulombs law. So I repeat again, similarities. Both laws obey, or both laws are inverse square laws. Second is both law obey superposition principle. Differences. In Coulombs law, the source of electric field is a charge at rest, which is a scalar quantity. But in Biot-Savart law, the source of magnetic field is a current element, which is a vector quantity. Second difference is there is an angle dependence in Biot-Savart law, which is not present in Coulombs law. Then third difference is electric field is along the line joining the charge and the point under consideration. But magnetic field is perpendicular to the current element and the line joining the current element and the point under consideration. Okay. And you have to remember one more important point. See, if I multiply mu 0, you know, permeability, into epsilon 0. Okay, mu 0 into epsilon 0. Find the product. And again, you multiply and divide by 4 pi. Value will be same. 4 pi epsilon 0 mu 0 divided by 4 pi. The value is same. But 4 pi epsilon 0, you know the value. 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. So we can write this as 1 by 9 into 10 raised to 9 into mu 0. What is mu 0? 4 pi into 10 raised to minus 7 divided by 4 pi. So you can cut this 4 pi and 4 pi. Okay. This can be written as 1 by 9 into, see that 10 raised to minus 7 you take to the denominator, 10 raised to 16. Mu 0 epsilon 0. This again you write as 9 can be written as 3 into 3. So 3 into 10 raised to 8 the whole square. But you know 3 into 10 raised to 8 is speed of light, c. So we can write mu 0 epsilon 0 is 1 by c square. So c will be equal to, c square is 1 by mu 0 epsilon 0. C equals 1 by root of mu 0, epsilon 0. This is an important result. So, you know, the permeability and the permittivity. Epsilon 0 is known as permittivity. Epsilon mu 0 is known as permeability. Okay. The speed of light is related to the medium, but its permittivity and permeability. This is an important result. Okay. So, dear children, today I end the class now. Watch the video, share the video, like it. Okay. We'll meet again in the next class. Goodbye.